So we were discussing about the transmit receive earth stations, right? And we have seen its structure. Okay, we have seen that it's going to be a very huge structure. Okay, wherein it has to receive a lot of signals and also transmit information. So the main thing here with this transmit receive earth station is that it not only receives but also sends information. Okay, so that's the best part about transmit receive earth station, right? So you can see that there are equipments here. Okay, and up converters, modulators, power amplifiers. Okay, before that combiner. So after combiner, it's going to be a wide band signal, and then power amplifier. Okay, and then the reverse happens. So this was all discussed in our previous classes, right? So today we will continue our discussion, okay, about this uh, transmit receive antennas, okay, and we'll try and understand as to why it is important and what are its features. So for the antenna, okay, which is shown, as I told you, there can be problems not only with the direction of antenna getting changed, but also with respect to the snow and with the ice formation on the antennas. Okay, so what happens is if there is fully snow covered, okay, these signals which fall here, okay, should be reflecting back. So if that doesn't happen, okay, the signals which actually fall here, okay, should be able to reflect back and you know transmit the information. So if that doesn't happen, okay, then it becomes difficult, right? Okay, so as I was mentioning here, okay, your signals that are transmitted, okay, should be able to uh, reflect back, okay, should be able to we should be able to get maximum signal, right? But if this surface is actually covered with snow, okay, then it becomes difficult for this kind of a transmission to happen. So what we do is we try to clear them up, okay, and this is possible only with minute heaters that can be employed throughout the structure. So what happens is as soon as when the snow falls on this, okay, when there is snowfall, okay, then automatically all those will get melted and slowly it will drip away in the form of water. Okay, so heaters are employed for this purpose, and as I mentioned you previously, okay, it's very difficult to maintain such huge structure, okay, because the base needs to be very strong. Okay, we should make sure that it is screwed in properly. Okay, and uh, because it's going to get exposed to a lot of rain, okay, sunlight. So this structure also should be made sure that it is stable. Okay, there should not be movement along this direction. Okay, it should be as stable as possible. So which means we have to make sure that in whatever angle the dish is set up, okay, that should be maintained without having any kind of uh, distractions for the signals to pass through inside. Okay, so here now we will be looking into the information, okay, where we will be utilizing this transmit receive antennas. Okay, even though you can see that it is very much used, okay, in geostationary satellites. Okay, but as we have discussed extensively, okay, there can be possibility of this kind of drift that can happen. Now when I say a drift, okay, it means that there can be chances that there is a small deviation from the angle that it is actually uh, set to rotate. Okay, right. So there's a small drift that happens. So we have to make sure that this drift also doesn't happen, because that also causes error, due to which the antennas doesn't receive proper signals. So ultimately, this TT&C should be able to track and control the position of the satellite. Also, making sure that the signals transmitted and received are at its fullest potential. Right. This combined with very narrow beam of large earth station antennas means that some provision must be made for limited degree of tracking. Okay, so we should make a lot of arrangements, making sure that these arrangements are done in a much proper way. Step adjustments in azimuth and elevation may be made under computer control to maximize the received signal. So this is also one important factor, okay, wherein using computers, okay, we can actually control the signals. When I say control the signals, we can make sure that our antenna is controlled with the help of a motor. Okay, just like how we saw for X, Y, and Z axis. Okay, we saw few motors which actually helps in the positioning of these solar panels. Okay, similarly, these antennas that we see can be controlled with the help of computer. So what's the advantage of having a computer controlled? It's only because we can make sure that precise information can be sent, and the angle, okay, even the smallest step size can be controlled. So you can think of your stepper motor and your DC motor. Okay, so the same concepts apply here, wherein you can actually position your antennas, okay, towards the left, right, north, or south, okay, based on the uh, amount of signal that you have to receive. Okay, so ultimately we have to make sure that we are maximizing the received signal. Okay, so that should be our main importance. Okay, right. So the next one, the continuity of primary power supply is another important consideration. Okay, when we think of this transmit receive earth stations. Now, now the power supply required is too high. Okay, that's because it needs a heater. Okay, there are a lot of motors involved, wherein the position of this satellite and this antenna has to be tracked and controlled. Okay, so the power supply, okay, there should be constant power supply, and if in case there is a power surge, or there is a power outage, or there is a power cut, okay, so we should be able to switch immediately to alternative forms of energy. Okay, it can be probably a UPS, or probably a higher or a bigger batteries. Okay, of course, generators will be employed, okay, instantaneously as soon as the power cutoff happens. Okay, so what I'm trying to say here is there should be constant supply, okay, of this power to these antennas. So the best thing here is to make it uh, uh, be connected either to a power line, okay, and alternatively to a backup line. Okay, so in such situations, okay, when there is a power outage, the backup comes into picture. Okay, right. Apart from the smallest stations, power backup in the form of multiple feeds from the commercial source or from batteries or generators are provided. Okay, so as I told you, batteries are used, generators are used. Okay, feeds from commercial source. Okay, commercial power source, for example, you can think of Discom. Okay, so that becomes your commercial power source. Okay, so all these should be considered. So why is it so important? Because we cannot lose a second of information. Okay, either transmitting or receiving. Okay, because it is very important for us to keep track of things. Okay, right. If the commercial power fails, batteries immediately take over with no interruption. So we want this. Okay, without any interruption, immediately uh, it should switch over to a different alternative supply. At the same time, the standby generators start up, and once they are up to speed, they automatically take over from the batteries. So it happens in a step by step. Okay, the first thing is your commercial power. Okay, and the second thing is immediately it switches to batteries. Okay, because generators do not immediately produce the required amount of energy required. So immediately after power fails, it goes to second source, which is nothing but your battery. Once the generators, okay, generator is your third one. Once the generators are in full potential, okay, then from the batteries, it's actually going to switch back to generators. As soon as the power comes on, okay, automatically it will go to step one, wherein it is relying on commercial power. In between, okay, in between 1 and 3, when there is usage of this battery, okay, when battery is being used, so in that point of time, after it shifts from 2 to 3, okay, that is from batteries to generators, the batteries also get simultaneously charged. Okay, so ultimately we should make sure that these batteries are of high capacity, and they will be able to store a lot of amount of charge. Now, as we know that there is a lot of technology improvements in the field of power consumption in the field of batteries, right? So we were using lithium ion, right? And nickel cadmium. So all these technologies, all these chemical combinations are researched in an extensive way, and we make sure that the batteries are of high performance. Okay, you can even think of the hydrogen cells. Uh, there's a lot of research happening in hydrogen cells, so even this can come up. Okay? So ultimately, we should make sure that our antennas do not fall short of power. It should be always connected. Okay, and it should be up and running every time. By the time your generator gets into its full potential, uh, the batteries actually supply the required power. So batteries should be actually of high potential, okay, wherein it should be able to supply. And see, ultimately when you're connecting, when you're communicating with a satellite, okay, there is a lot of high frequency, there's a lot of conversions that happen. Okay, now as you can imagine, we are employing Ku band and C band, right? So under Ku band, if you can imagine, there is a lot of frequency at high frequency levels. So once these signals comes down, okay, with the help of down converters, we actually employ it to our terrestrial stations, which is also called a base station, right? So once these are employed, then only, okay, we will be able to use the frequency. So which means batteries are very much involved here in the process of conversion, in the process of transmission, and also in the process of uh, communicating, okay, between the transmitter and receiver, okay, which is nothing but your base station. Base station is nothing but your uh, earth station, okay, and your uh, satellite. Okay, so we need to have preciseness. Okay, we need to make sure that signals are not lost just because of some underrated or you know uh, batteries. So whatever stuff that is being used, okay, we should make sure that the quality is top notch. Okay, because we cannot afford to lose a satellite just because of you know uh, saving cost in battery. or generator. Okay, so quality is of utmost importance here. Okay, so this is going to be our end of module 4. Okay, and we will be starting off with module 5, which talks about the satellite, mobile, DBS, and specialized services. Okay, so up till now, okay, do you have any doubts in the topics that we have discussed so far? If anything as such, yes, we can go ahead and have a discussion. The main topics that we have seen so far is MATV, community, receive only, okay, and in receive we have indoor, outdoor, okay. So these, were the things that we had discussed so far, okay. Ultimately, we are talking about, we spoke about the Earth segment, okay, which means communications happening at the Earth station, okay. So different types of communications were seen. So any doubts here, students? The topics that we have discussed so far? We could have a discussion if any doubts here. Yes, Satish Hegde, is it all clear?
Yes, sir.
Okay, fine. Santosh, Shalini, Ruth, are the concepts clear?
Yes, sir. Sir, I'm actually traveling, so that's why I can just hear you and I'm not able to speak that well, sir.
Okay, that's fine,
There's
but the concepts are understood, right?
yeah.
Okay, fine. So that's important, wherein once the concepts are understood, it will be easy for us to represent it in our scripts. And Kishan, Anisha,
No doubt, sir.
it's all fine. Okay,
Yes, sir.
okay, okay. How about Pranay, Likit?
No doubt, sir.
Okay, good. Kavya,
Understand, sir.
Likit, no doubt, right?
No, sir.
Okay, fine. Then how about Kavya? Kavya Shri? Raghav? Yeah, Kavya, go on. Yes, Raghav.
Sure.
Okay. Then Saimanti?
Yes.
Okay, fine. So having
Sure.
understood, yes, thank you. So having understood the concepts here, okay, where we had exclusively spoken about the communications that happens in the base station. Okay, when I say base station, I'm referring to the Earth station. Okay, do not get confused with the base station of your mobile base station. Okay, that is different. That's altogether a different concept. Okay, so I am referring to the Earth station. So we have discussed extensively about what all communications that happens in our Earth segment. Okay, it could be with respect to only televisions, it can be with respect to our entertainment, with respect to communication, okay, and with respect to satellites, and what kind of information, okay, and how these things can be related one to each other, and what were the pros and cons of these communications were all discussed, right? So I hope these were clear for all of you. One important thing that you will have to know here in this unit is, okay, in this module is, of course, it's simple, but then, you'll have to precisely know the block diagrams, okay, and maybe the frequency ranges are required for these, okay. Even though, for example, if you're not able to draw the television properly, that's fine. Okay, but those informations that are involved, okay, is at most importance. Uh, okay, so just make sure that you remember these frequency ranges. Okay, most of the time we have used the KU band and C band. Okay, so that should be simple. And how much of range and how much of FM channels that it can accommodate, and how much of width for each channel, right? That also can be remembered. Okay. And in your indoor unit, okay, what is IF? The importance of IF, and how we get about with the number. Okay, and with respect to your MATV, okay, master antenna television system, here also you can just check with the block diagram as to how important it is. And we have seen the usage of your converters, okay, low noise amplifiers and converters, and receivers, modulators, channel setup, okay, the group selector, how we can actually select which channel to employ, right? One thing about community is that it's a wider range, one extension of your master, wherein master is only suitable for a building, an apartment, for example, but community can be for a whole area. Okay, right. So the major thing that was discussed here was with respect to transmit receive stations. Okay, where the importance of backup. Okay, the importance of having two standby devices if in case one fails. Okay, in the above section, if one fails, then it would be easy for us to employ uh, the standby chain, okay, which will actually kick in if the previous link is lost. Okay, when I say previous link, say for example your modulator isn't working, so in that scenario your link is lost, right? It cannot actually go to the up converter, okay, because this whole device is gone. So in that scenario, okay, this will come in, where we can have standby devices. Okay, it's always good to think of two backups in such fashion. Okay, detailed diagram is also needed when a question is asked with respect to transmitter receiver station. This question will be important. Okay, most importantly, three different types of questions, three uh, configurations are important: transmit receive, master antenna television system, and your community. Okay, so these three are important here. You can expect these kind of questions in your examinations as well. Okay, right. So now we will move into module 5, okay, which talks about the GPS, okay, mobile, then satellite mobile, then some other special services that is involved. Okay, right. So satellites provide broadcast transmissions in the fullest sense of the word, because uh, antenna footprints can be made to cover large areas of Earth. So that is one best thing that happens with regards to satellite. Okay, you can actually cover a large area. Okay, unlike your normal antennas. Okay, this can actually help us in covering a greater geographical area. Okay, which doesn't happen with the other antennas or communication systems. Right? It can go beyond a country. It can also cover the neighboring countries. Sometimes as big as a continent, it is capable of covering. Okay, so that is what is referred to footprint, antenna footprints. Okay, so the higher the footprint, the better, because the coverage is good, right? So that's why you can actually see that these satellite phones are given to military personnel, okay, wherein even if the terrestrial networks are lost, they will be somehow connected to another more reliable network, okay, because in some scenarios, okay, there will be a real-time communication happening wherein they cannot afford to lose even a millisecond of information or a millisecond of signal. The network should be reliable. There shouldn't be any loss of data. There shouldn't be any loss of packets. The voice shouldn't break. Okay. So these are all what to say, high priority communication that needs to happen. Right. The idea of using a satellite to provide direct transmissions into the home has been around for many years. Okay. So it's not only just, it has been started with a few years. Okay. Since many years we are employing. The first one was with Russia. Okay. If you can just go back to the history and check Russia and then US. Okay. Then ultimately the other countries joined in. And now not only that, we are even exploring different planets. Okay, um, for purpose of habitation, for purpose of exploration, for purpose of scientific investigations. And the services provided are known generally as DBS. Okay, so those things which we take directly from the satellite, okay, is termed as DBS. In fact, we have seen about DBS in our previous module as well. Broadcast services include audio, television, and the internet services. So not only with regards to transmitting information, but also we use it for entertainment purposes as well. Okay, so it can be with television, or it can be with audio, or it can be with providing internet services. Right. So some of these things has to be kept in mind, where satellite just cannot be, we just cannot invest so much of finance and use it only for one purpose. Okay, but instead we employ it in such a way that we can take uh, multiple usages from a single satellite. And as I was mentioning, we can use it max to about 25-30 years, and once that is gone, okay, then slowly we leave it to die by itself. How do we do it? We just leave controlling it. So once we stop controlling it, one day it will just hit an asteroid, or probably it will hit some other meteor, and it will get destroyed. So ultimately, why do we do that? Does someone have an answer for that? Why do we go with sending the satellite into a graveyard? Why is it done? Yes? Why do we send a satellite to a graveyard? Because the operating costs are higher. Okay, so instead the information that is received from the satellite is much less reliable, and spending money in operating it doesn't work out. Okay, so instead what they will do is, instead of spending more money in maintaining with less reliable information, they try to stop controlling, and ultimately the satellite would be destroyed. Direct broadcast television is also called as digital TV. So these are some of the information that is utilized, okay, with the United States DBS systems. Okay, just an example I have put up here as to what is high power, medium power, and low power, and for what it is being used. So towards your extreme left, you have downlink frequency allocation, which is in gigahertz. Okay, so all this Ku band, C band. So if you want to utilize low power, okay, then you can always step down the frequency to 11.7. See, initially it's about 12.2 to 12.7, but if you are very much concerned with the medium power, with the power consumption, then you can always go ahead with stepping down the frequency. If you still want to, okay, then it's possible that you can operate it in C band. Okay. So this C band is typically used in our Earth stations because we downgrade the signal, and while transmitting from the satellite, it doesn't need to be in high frequency. Okay. But while we are transmitting from Earth station to the satellite, then we need to employ higher power signals. Okay, so the power consumption, ultimately the result that you can draw is the power consumption for those signals for transmitting from the earth to the satellite is higher than the signals that is coming to the earth station from the satellite. Okay, so uplink frequency, okay, uplink frequency is 17.3, and here it's about 14, and if you want to operate it in low power, then it becomes 5.9 to 6.4. Space service. Okay, so what is it going to serve as? So it's used for broadcasting information. It is used in FSS, fixed satellite services. Okay, wherein we do not move the satellite. Then primary intended use, ultimately we'll be using this for DBS. Then point-to-point communication, FSS is for point-to-point communication. Okay, the same thing here. Allowed additional use, yes, point-to-point can be done. Here DBS can be employed with medium power, and with low power, the maximum that you can do is DBS. Terrestrial interference possible. Uh, so with high power and medium power, no, but with low power, yes. So that is one of the advantage of having operating a frequency at a higher range. Okay, so if you operate frequency at higher range, the interference is actually very much less. But then the power needed to transmit and receive these signals are higher. So ultimately, it depends on what kind of signal that you want to employ. Do you want to employ a high priority signal without any loss, or you're okay with just transmitting the information with a little bit of noise? Then satellite spacing degrees. Okay, each satellite is spaced about 9 degrees apart. Okay, then 2, and here 2 to 3. Right. Satellite spacing is determined by ITU, okay, International Telecommunication Union, and here it is FCC. Adjacent satellite, okay, FCC I have put up for your explanation here, which is Federal Communication Commission. Okay. Adjacent satellite interference, here also it doesn't happen because they are spaced apart a little further. But here, since it's only about 2 and 2 to 3, so let's take it as 2.5. So interference happens. Then EIRP is about 55 to 60, and here it's about 45, and here it's about 35. So EIRP is less with low power. As the power increases, okay, the EIRP also does increase. Right. So these are some of the characteristics that you can keep in mind. Questions can be asked based on these. So having understood all these concepts with regards to high power, medium power, and low power, and the various parameters involved, okay. So now we will look at a different information, okay, where the orbital spacing that happens between each satellite. Now we cannot keep these satellites very close to each other. We have to make sure that these satellites are actually spaced apart. Okay, so this is the kind of information that we have okay, with regards to the satellite spacing. Okay. Orbital spacing is 9 degrees for the high power, so adjacent satellites interference is considered non-existent. So here you can see, for every angle, okay, for 175 degree, 166, okay. So this is about, yeah, 9 degrees. If you can plus 166 with 9, okay, so that should give you 175. 57 plus 9 should give you 166. Okay, yeah. So ultimately, here we are trying to have different angles for different satellites, so that whatever information is passed between one satellite to another satellite, just in case, is almost non-existent because they are spaced apart. Okay, so these are some of the data with respect to US and its orbital positions. Okay, direct broadcasting service orbital positions. So you can just have a look where your, these are all kind of service providers. Okay, your DBSC has about 11 satellites in 175 degrees, and then uh, another 11 in 61.5. Direct TV has 27 in 157 degrees. Okay, this is the satellite location. Okay, satellite location, just like how we have coordinates here. Okay, if you open up your Google Maps, you will have something called plus code. Okay, so if you click and on the plus code, and if you can save it, that is a unique code for each location. Google has generated a random plus codes. Okay, or I rather not say random. Okay, it is actually unique for each area. So if you can just provide the plus code, then you can just directly search for that, and the pinpointed location can be viewed. Okay. Similarly, you can see that from EcoStar, you have different satellites. Okay, from USSB, then unassigned. These are all unassigned, which means it can be utilized. Yeah, right. So now, why is this important? Any idea as to why is it important? Why is it important? Because we can make sure that these are spaced apart, and we know exact information as to how many satellites are there and how many can I employ. Okay. Right. So the next thing that we will be looking into is these kind of contacts. Okay. uh, the same information is here. Okay, and how they are connected. Okay, so if it's connected to 175, then it's here 166, 157. So this is how these satellites are placed with respect to north pole. Okay, so these are some of the information that you all need to know. Okay, so I think probably we will stop here. Okay, and we will continue our discussions in our upcoming classes, where we'll be looking into the power rating of the transponders, and how much of usage, the frequencies, in what range they operate. Okay, what is this RHCP, LHCP, all this we will be looking into in our coming classes. So any doubts you have so far, students? Any doubts so far? Anything to be discussed?